Physical Applications Part 2. In Part 1, we saw that the work required to lift all of the fluid out of a container to the outflow level is given by this integral, where B is the height of the fluid, rho is the density of the fluid, G is your acceleration due to gravity, A of y is the area of the horizontal slice at the level of y, and h is your outflow level. How much work is needed to pump all of the water out of a full cylindrical tank with a height of 10 meters and a radius of 5 meters? The water is pumped to an outflow pipe 15 meters above the bottom of the tank. The tank is cylindrical with a radius of 5 meters. Notice the way the axes are positioned to make the problem easier. Water has a density of 1,000 kilograms per cubic meter. The height of the tank is 10 meters and the tank is full of water, so the water level is 10 meters. The outflow pipe is 15 meters above the bottom of the tank, and we positioned the x-axis at the bottom of the tank. Since the tank is a cylinder with a radius of 5, the horizontal area at each level is just pi r squared, or 25 pi. Set up your integral. I'm integrating from 0 to 10, my water level. Rho times G is 9,800. A of y is 25 pi. The outflow level is 15. It's time to integrate. After you integrate, evaluate. So you get about 77 million joules. The hydrostatic pressure on the face of a dam is given by this formula, where G again is our acceleration due to gravity and rho is the density of water. A is your water level, and W of y is the width of the wall or the width of the dam at height y. Let's do an example. A large vertical dam in the shape of a symmetric trapezoid has a height of 30 meters, a width of 20 meters at its base, and a width of 40 meters at the top. What is the total force on the face of the dam when the reservoir is full? So let's first figure out what our water level will be. The trapezoid has a height of 30, and the dam is the reservoir is full, so the water level goes all the way up to the top of the dam. So A is equal to 30. We need to find the width of the strip W of y at height y. We can see that that width is going to change as we move up and down the y-axis. So what is W of y? Notice the placement of the x and y axes. This will make finding W of y easier. Draw a pink line along the right-hand side of the trapezoid. The slope of the pink line is 3. Then, using the point 10, 0, I get the equation of the line. Solve for x. Solving for x gives me the width from the y-axis to the pink line. So for a given value of y, the horizontal distance from the y-axis to the pink line is given by x. Now we want twice that. So the width of the dam is 2/3 of y plus 30. And we're ready to integrate. Before doing that, we really should simplify our integrand. And then go ahead and integrate and evaluate. When the dust settles, you get 1.18 times 10 to the 8th newtons. And that is the hydrostatic pressure on this dam when the reservoir is full. You take care and have a great day.